Well, I suppose we can go ahead and get started. It looks like we got the recording going. Thanks, Mitch. So welcome, everyone, to the first technical discussion for the CIRP program for FY25. We're happy to be back and presenting on ongoing research, and we're kicking off with one of our FY24 new starts, for which we've got quite a bit of work going into over the next couple of years. So we're excited to share the basically first 6 months of this project and the kind of where we're going past on this, and maybe generate some interest too amongst the researchers and folks that are calling in from the district and abroad. So we welcome all discussion, any suggestions y'all have. If you have specific questions or interests and you want to share them in the chat or unmute yourself, you're welcome to jump in at any time, ask questions. And then, of course, afterwards, if you just want to get in touch with the researchers, we just really welcome you to share anything that you have ongoing that's relevant to the ongoing work. This research was one of the top navigation statements of need that came out the year prior in the 23 FRARG. I do math right. And then again, it came out very highly ranked in the 24 FRARG with a follow-on statement of need, which is further driving funding from this program into this type of work where we're looking at remotely sensed products that support analysis and prediction and better understanding of hazardous shoals in coastal inlets. So we're excited to get some more folks on the team and also get more insight from across the Corps. So we, again, welcome any and all participation. So thank you for joining us. And as always, I can hand out professional development hours for those of you that do your PE certifications, things like that. So if you need that, send me an email. It's a quick little form to sign, and I can get you back the 1 hour cert for joining these calls. And I think that's all I have to kick us off. So we'll go ahead and turn it over to Justin and Alex.
Thanks, Tanya. So yeah, we're excited to present on sort of the 6-month progress update for our project remote sensing of hazardous shoals. We'll be talking about some insights we've gleaned from a practitioner workshop, literature review, and some pilot testing that we've done over this sort of short sprint of the project. As Tanya said, my co-PI is Alex Ostoich, and we both sit down, so we're both in the Coastal and Hydraulics Lab, but we sit down at the Joint Airborne LiDAR Bathymetry Technical Center of Expertise in the Mississippi Gulf Coast. Before we dive into these three sort of subtopics of the project, I wanted to introduce you to the project team. So there's not only Alex and myself, but also Katie McPheron, who's a coastal geomorphologist with an inlet processes background, Copeland Cromwell, who's also a coastal geomorphologist with a remote sensing background, who's an intern for us this summer and is now a DoD SMART Scholar with this team. And then sort of the fifth soon to be announced member of the team will be our ORISE fellow. This will be about an 11-month position for a postmaster's candidate. We've made our selection waiting on the sort of official word that that selection has been passed forward and that the candidate has accepted it, but that person will have a little bit of a Python and a really strong GIS background as well. With that, I'm going to kick it over to Alex, who's going to talk about the motivation for this work.
Yeah, thanks. So some of you might have heard this, presented before, but I just want to kind of take it back to how this work started. We first started playing around with image classification on inlets when we were doing, Justin and I were doing a reimbursable study on Barnegat Inlet in New Jersey. And the point of that study was to look at volume change on the beaches, adjacent to the inlet, and that was using our kind of JavelTex GIS toolboxes. In that project, though, we also took some time just out of interest to see how well image classification might be able to do in delineating some shoaling around the inlet, suspended sediment, et cetera, like what it can, what it can do. So we did a really basic kind of ArcGIS supervised image classification using just NAIP imagery. And the images here show the results of that kind of basic analysis. But the results did show some promise in terms of like delineating some shoals and, a good amount of suspended sediment with cleanup needed. But with that, we kind of got motivated to pursue image classification in inlets a little bit further. Particularly in terms of inlet shoaling, we do have data that is used to track shoaling, hydrographic surveys, LIDAR, but while that data is robust and does give good shoal tracking, there's also a temporal gap with that data. For example, the National Coastal Mapping Program takes LIDAR on a 5-year cycle. So in terms of tracking shoals that do change frequently, there is a missing middle that we are thinking image classification might be able to do a good job at filling in terms of tracking shoal migration. I can go next slide. So after that, we did some research on classification at inlets, and we found a tool that, we read about in a tech note from 2004, Connell and Zerillo, which seems familiar to people in here, but it was for ArcView, which is an early GIS version. But this tool basically took the user through steps of image classification at inlets. It included, image rectification if there was no coordinate system attached, some image analysis that included playing around with the histogram scaling and changing around the values to, get different visuals and reflectance numbers pre-classification. And then it had a built-in unsupervised classification of imagery, which has the user just pick how many categories they want, and it does like an ISO clustering method to then just output a classified image. And I believe it also did have an extension to it that enabled supervised image classification. It had a kind of shoreline extraction feature which would walk through selecting shorelines and land masses that would then allow you to take them out to only look at water features. And it also is capable of importing XYZ BAPI data to look at that with the classification. So we found this, read through it, and, this was a really cool tool. And we thought that, we could try and update it and create a newer version of something like this in terms of classification at inlets for shoal detection. Go next. So we actually put forth our proposal in response to 2 statements of need. The first one was from Monica Chaston from the Philadelphia District. And that statement of need mainly talked about the need for new tools to monitor shoals on shorter timescales than what's available currently, to really kind of understand and help predict temporal changes, particularly in areas where they are hazardous, they are dynamic, and they pose problems for navigation. The other statement of need was from Rachel Malberg, and that was particularly focused on the Great Lakes. Muskegon Harbor specifically has been having a lot of shoaling issues lately that has caused unexpected vessel groundings, and they are looking for some research to help understand why those shoals are forming. So we are hoping that with this project, potentially having Muskegon Harbor as one case study site for these methods, as well as another proposal that we put forth through RSM to just build a basic sediment budget at Muskegon Harbor, we can kind of use those 2 to help build a complete picture that pretty thoroughly responds to that statement of need in terms of understanding what's happening there. Let's go next. So this is our basic project path that we've shown before. For FY24, when it started, we did a kickoff workshop that we'll get into a little bit deeper in the following slides, as well as a literature review that we're finalizing now, and we'll also talk about that in a little bit. But for this FY25, right now, we're working on kind of finalizing our methods and identifying our case study sites, which we have like preliminary identified sites. subject to change. We will talk about those a little bit later as well. For the rest of the FY25 is going to be mainly focused on implementing these methods on these case studies, doing data inventory, and then at the end, outlining what we want our tool to look like, having some more PDT engagement, and publishing our case studies so far. And FY26 is primarily going to be tool development and then additional PDT engagements, conference presentations of our work, and the final products to be, completed in FY27. Right now, we're looking at an ArcGIS Pro Toolbox, which is, we'll see where the project takes us, but that's kind of the goal at the moment. And then various publications outlining both our case studies as well as the tool. You can go next. All right, I'll kick that back to Justin, talk a little bit about the PDT meeting, the kickoff meeting that we had.
Great, thanks, Alex. So yeah, we had the opportunity to engage this mix of district folks as well as ERDIC folks that you see on the slide here, brought them together for a virtual workshop. And during that workshop, went through a whiteboarding exercise with them. And then, excuse me, after the workshop, held these one-on-one and small group meetings with folks to facilitate additional discussion as needed. And so what we did specifically at that workshop was took this multi-tiered approach to getting feedback. And so it started with something simple, which is just a structured slide deck with some background material. And then we followed that with a series of additional slides that had questions, but for each of those questions, participants had the option to participate in a few different ways, whichever they were most comfortable with. So they could simply unmute their microphones, hop in, and start a conversation that way. They could post in the chat. We were taking notes of sort of those ongoing conversations, so those chat posts. And then I think what was really nice is, of course, not everyone's comfortable with being so direct in their communication. And so we also had this sort of anonymous whiteboard feature. And so for folks that are interested in this, it's very similar to like Google's Jamboard, which is now going away. And so we had to find this alternative, which we turned to excalidraw.com, which sounds funny, but it was really simple. There's no user account required, and it was very nice and easy to like set it up and for folks to scroll through. We really had no tech issues. So if you're looking for sort of a whiteboard option for your facilitation, we liked this and thought it worked out. And we captured some really nice feedback, and I'll walk us through that right now. So for example, some folks noted that right now, sort of the like core problem, right, that Alex kind of walked us through with that Barnegat example is that often shoals in our navigation channels, particularly our coastal inlets, those shoals are shifting too quickly to be able to monitor them with existing tools on a reliable basis. And in particular, we heard that the districts would ideally like to better afford quarterly hydrographic surveys, but we were given an example sort of dollar amount for, of course, things are going to vary a little bit on footprint and stuff, but these hydro surveys can run 40 or 50K per survey internally, and so that adds up quickly for one of these smaller shallow draft projects. And so that, of course, leads to the sort of root question here. But one of the things the districts want to see in particular is being able to map the trajectories of shoals in an inlet. And so something along the lines of like, where is the shoal located and what is the probability or trajectory of the shoal, right? So the probability that it's going to persist and what's its trajectory. And can we sort of get to this point where we're predicting the migration rates at these inlets if we have sort of higher resolution, higher temporal resolution data. And so as a qualitative product, what some of the folks in the room would love to see is sort of a video looping of just being able to see the shoals migrating at any particular inlet. We also sort of discussed what would be the satellite imagery sources for such a tool, right? There's your your sort of go-to options of Landsat and Sentinel because they're easily, readily available and public. But if we turn to something like Planet, which at some sites can have almost bi-daily imagery, we have this higher temporal resolution and be able to then sort of more readily select imagery that had better cloud conditions, wave conditions, things like that. Another point of discussion that came up is sort of the fact that obviously the US is huge, and so you have this spatial and regional variability in inlets, not only in terms of their behavior, but also in terms of things like water clarity. And so how can this tool be applied in different regions? And in particular, could this tool be applied to West Coast inlets? And it was suggested, obviously, that we should pick a West Coast case study as well. So we'll get to that actually towards the very end. And then last but not least, the piece of feedback that we've taken to heart is that once this tool is developed, we're really going to need to make the case about how applicable this is to district work and to make sure that we've got workshops that kind of go beyond maybe the lifespan of this 3-year project and increase sort of an engaged base of users where we really demonstrate, that this project, has spun up from district needs and is directly trying to address those. So we took all that to heart and dove into literature review. In that literature review process, we looked at over 60 articles, conference proceedings, reports, some theses and dissertations, and we broke up the tools that we could find in the literature into 2 sort of broad categories and then some additional subcategories. But at the broadest brush, we've got our non-satellite based tools and then satellite based tools. And so non-satellite tools include everything from your classic hydrographic surveys to airborne LiDAR, the radar inlet observing system, as well as imagery and video. So things similar to CoreCam. And then for satellite-based approaches, we reviewed satellite-derived bathymetry, and then we took a deeper dive into the focus of this work unit, which is image classification of inlets, and we also expanded that out to similar environments in order to have a broader array of papers to look at. And so what I'm going to do now is walk you through a few takeaways we had as part of that literature review. The first is about the reliability of remotely inferred bathymetry, and across the board, I think the results are actually really promising from a qualitative perspective, right? And here we're really interested in sort of like the plan form migration, right? That sort of top-down view of shoals around inlets. And for that, the literature holds a lot of promise. I think where things get more complicated is when you're starting to treat it as a relative bathymetry or put a value on it. But I think that the literature coming out of the CBATHY product, right, which is 20 plus years now of literature related to that, it shows a nice way to sort of robustly quantify things like bias and root mean square error. So you see example of that, but I think there'll be things we learn as we're going on that we can draw from. So for example, what is well known is what CBATHY, which is a wave celerity based approach to inferring bathymetry, that there's a bias that increases with depth, as well as, not surprisingly, your root mean square error increases with depth as well. Then, so as that water gets deeper, the accuracy of your bathymetry is lower. But we could compare that to airborne LiDAR, for example. It works similarly. Some other sort of another challenge that we identified is that particularly for inlets, wave celerity based approaches are feasible, but of course there are going to be challenges due to the complexity of inlet hydrodynamics. So you have not just waves but tides, and as those interact, it can make using those wave celerity based approaches a little more complicated. And so our takeaway here then is that this project basically needs to help fill a gap where at every inlet a celerity-based approach isn't going to work. But likewise, we recognize early on that this image classification-based approach or an index-based approach, whatever we settle on, is not going to fill the gap at every inlet either. And so what we're doing now is working very intentionally and directly and collaboratively with Ian Connery and Shannon Brown. They've got an overlapping work unit, and actually the end goal is basically that these two work units are combined. We have one tool set to kind of rule them all, where for some inlets it makes sense to use the celerity approaches, others it makes sense to use the image classification approaches. The other thing the literature review looks at briefly is shoal migration rates at inlets. It's something that came out of Monica Chasen's conversations with us, is that she just wanted a general sense of where those rates fall. And so we looked at a few papers and found that, not surprisingly, this varies wildly, but they range anywhere from those migration rates range anywhere from 100 to 1,000 meters per year at any particular inlet. And I think, as we refine estimates at the case study sites, we can start to think about, is that quarterly ideal survey frequency that was identified at the workshop realistic, or do we need something finer resolution? Is coarser resolution fine? For other sites, we'll sort of be able to dive into that soon. The other thing we looked at are some key indices that are often used in the literature for looking at shoals and bathymetry in general. And one that we honed in on really quickly is the normalized difference water index, as well as the modified normalized difference water index. Alex will be taking us on a deeper dive into this, but just know that it draws from the green and near infrared bands, as well as, for the modified version, the shortwave infrared bands. And two products that, as just a few examples, that use the normalized difference water index are COSAT, which I imagine most people are familiar with, right? But in the second step of the COSAT shoreline extraction process, the workflow uses the modified NDWI. And then another tool came out in the literature recently is Inlet Tracker, which tracks the thaw wag, particularly of unstructured inlets. But to aid in that thaw wag tracking process, they also use the modified NDWI. But one challenge we identified already in the literature related to NDWI is that NDWI itself is actually also used to track turbidity. And so we're going to have to keep that in mind, that, there's this potential, of course, to then mistake turbidity for shoals. Alex is going to walk us through our case studies.
All right, thanks. Okay, so most of our methods of development is happening this FY, but last FY, our team member Copeland Cromwell, who we mentioned briefly, took some time to do some pilot studies to implement some of the techniques that he found in his literature review for this, for our purposes, to see how well some NDWI analyses would work. So for his pilot studies, he looked at two locations, East Pass Inlet in Florida and Barnegat Inlet in New Jersey. And these two locations kind of fit what we're looking for in terms of, as Justin mentioned, we want to have kind of a geographically diverse case study locations to look at, West Coast, East Coast, Gulf Coast, et cetera. And we also want to have kind of different characteristics in terms of water clarity to see how well, what we build is going to work at different locations. Now, both of these inlets have decent ground truthing data available, which, is helpful in terms of checking the remote sensing. They've both been, constructed and maintained since the 1930s and are dynamic. In East Pass Inlet, there's a history of the thaw wag migration on the inlet, and Barnegat has ongoing dredging needs. There's persistent hazardous shoals there, and this is actually like one of the main sites that was kind of identified, in our talks with Monica Chasen, that could use, more shoal tracking tools. The difference between the sites, though, is that the Florida site, back one, sorry. The difference between the sites is the Florida site is pretty clear, and it's kind of, if you see the picture, it's a pretty ideal location for this kind of study. You can really see the shoals, and that makes for some good extraction, whereas Barnegat Inlet is in the northern Atlantic, it has much poorer water quality. So, you know, it would be interesting to see how well the tool can pick up on shoals in those locations as well. We can go next. So for this pilot study, we used NDWI, which Justin briefly mentioned it, but basically it uses the green and near-infrared bands and is often used to delineate water from land. Near-infrared band is very well absorbed by water, and the green band is kind of transmitted through and reflected back a little bit, and specifically reflected back from like off of land. So that ends up delineating water and land very well. In the case of underwater features such as shoals or some suspended sediment, the near-infrared band will be absorbed, the green will be reflected by the underwater features, increasing NDWI values often when you have suspended sediment or shoals, unless it's very turbid, which can then, you know, change NDWI values. So it kind of depends on the balance between absorption and reflection of those bands. In this example, this is the East Pass, Florida site. The first image is just a Sentinel-2 RGB image of the site. The second image is the NDWI calculated. And the third is a modified NDWI, which uses shortwave infrared instead of near infrared. The modified NDWI is often used because shortwave infrared and sometimes middle infrared are better absorbed by water. However, in our case, we saw that the NDWI performed decently better, and that has also been found in other locations like coastal inlet locations on the East Coast and Gulf Coast. So we then, you know, continued these pilot studies using just the normal NDWI. And we can go next. And based on some literature methods, Copeland kind of performed a few analyses on these sites. The first one here is created a transect on the NDWI image of East Pass, projected NDWI values onto the transect, and then plotted to show the difference in NDWI values. Now, the peaks in the plot, which correspond to the blue dots in the image, pretty well delineate what looks like shoal peaks from the calculated NDWI within the inlet and both at the ebb tidal shoal. We go next. And then just a little modification of that, we replaced several transects along the inlet and indicated the NDWI peak on the image itself, which seemed to outline the shoaling pretty decently on the image, and the plotted transect, which is the bold transect, once again shows the peak marked in the red X where the peak NDWI is, indicating bed forms. And go next. This is the same at Barnegat Inlet. The first image is just the RGB Sentinel-2 image, and the second image is NDWI calculated using the green and near-infrared bands. In this one, you can see some activity going on within the inlet, but a really pretty well visible kind of delineation of the ebb tidal shoal. You can go next. This is a similar analysis for Barnegat Inlet, where a bunch of transects were placed along the shoal, and the one in bold is the one shown in the plot. After removing, some noise using filtering, you can pretty well detect kind of the shoal peak shown in red and the overall shape of the shoal itself. Okay. So with that little pilot study, we definitely decided that those methods are what we are going to build on and use to kind of create our final workflow. Some challenges with NDWI is, of course, cloud filtering, and this is the case with any image classification, regardless of index or, what the application is. The first kind of video here is a year's worth of Sentinel-2 images with just a cloud filtering algorithm applied to them. But, a lot of them are usable, but some still not so much. That only does so much in terms of eliminating clouds, especially on the really cloud-heavy ones. The second set there is just hand-selected images, which make for much better results if you're looking at all of them, but they do reduce the number of images that you have. So that's always a challenge in terms of image classification. In addition to that, for our purposes, NDWI, is also used for waves, as mentioned, turbidity. In our pilot study, it also captured, vessel wake in the imagery. So it's going to be kind of on our minds moving forward. How can we just isolate shoals from everything else that NDWI captures in this imagery, so that doesn't produce errors for us, or produce fake features that are not really there. Next slide. So as we develop our methods, a big question, of course, is kind of what our final products are going to be. For that pilot study, we did a simple transect and plotting NDWI values to see if we can find shoal peaks along the transect. But what we ultimately, want to do in response to the district needs is kind of create a product that can track shoal migration and shoal change. So, the big question is what that's going to look like and what we can get out of our imagery. For example, are we just mainly going to be trying to track shoal peaks and where that peak is moving? Or are we going to be trying to actually outline the entire shoal formation? How much of it can we capture, and what will our final analysis be? How are we going to quantify migration? So that's a big top of mind question that we're answering now as we develop our final methods. So kind of in summary, some of our key highlights of the project so far is the PDT engagement, where we got really good feedback for, what's needed and some good advice for, for the project moving forward. Literature review is currently being completed, and, with some good takeaways from the literature to keep in mind as we build our own methods. And mainly NDWI is identified as the most common index in terms of water delineation, and that's what we're going to be focusing on and trying to kind of improve upon the pilot sites for the project going forward. The image here shows part of our next steps is to finalize our case studies. Here we have kind of preliminary sites that we've chosen that encompass both, sites that are of high district interest as well as some kind of personal interest sites that, are subject to change, but that's kind of where they stand at right now. And next step, along with kind of solidifying the study sites, is continuing to collaborate with the Connery and Brown work unit to see how our tools can either work in tandem or kind of combine into one at the end, to be able to use both this, image color classification method with their rate celerity methods and have a more complete picture of shoal change. All right, and that, I will open it up to any questions or discussion. Thank you for hearing our presentation.